Welcome to Astronomy Daily, your go-to podcast for the latest news from across the cosmos. I'm Anna.
And I'm Avery. We're thrilled to have you join us today as we dive into some truly fascinating updates that are reshaping our understanding of space.
Absolutely, Avery. We'll be looking at the evolving lunar race with some significant developments from China's space program that could see them reaching the moon sooner than anticipated.
That's right, and we'll explore what those geopolitical implications can mean for the future of space exploration. Plus, we'll journey deep into the galaxy to witness a stunning cosmic discovery. Astronomers have captured an image resembling the Eye of Sauron, revealing secrets about powerful blazars.
And for all you planet hunters, we'll delve into new research suggesting that many exoplanets might be far larger than we ever believed, completely changing our perspective on alien worlds.
Then, as always, we'll wrap things up with our launch roundup, including the much-anticipated 10th flight of SpaceX's Starship and a unique biological mission sending mice and fruit flies into orbit.
All right, Avery. Let's jump right into what's quickly becoming the most talked about development in space exploration, the new space race. China's secretive space program has been making some incredibly significant strides, and it seems they're firmly on track to achieve their lunar ambitions.
They certainly are, Anna. In recent weeks, the China Manned Space Agency, or CMSA, has reported some major milestones. For instance, on August 6th, they successfully tested a high-fidelity mock-up of their 26-ton Lanyue Lunar lander. This test was quite impressive, conducted outside Beijing using giant tethers to simulate lunar gravity, as the vehicle fired its main engines and fine control thrusters to land and take off from a cratered surface.
That's a huge step. The CMSA even released a statement calling it a key step in their manned lunar exploration program, and marking the first time China has carried out an extraterrestrial landing and takeoff test for a manned spacecraft. They also reconfirmed their plan to land astronauts on the moon before 2030.
And it wasn't just the lander. Just last Friday, the CMSA and their state-operated rocket developer, the China Academy of Launch Vehicle Technology, successfully conducted a 30-second test firing of the Long March 10 rocket's center core. This rocket uses 7 YF-100K engines that burn kerosene and liquid oxygen. And the primary variant will combine 3 of these cores to lift about 70 metric tons to low Earth orbit.
So what we're seeing here is demonstrable progress across all 3 major elements of their lunar program: the large rocket to launch a crew spacecraft, the human-rated spacecraft itself, and the lander to take astronauts to the surface and back. This really suggests that China is well on course to put their taikonauts on the moon before the end of this decade.
It does. Now, for the United States and its allies, there's always been a bit of a been there, done that attitude, given NASA's Apollo program landed humans on the moon nearly 6 decades ago. NASA's Artemis program is, of course, aiming for something different, focusing on sustainability with in-space propellant storage and refueling technology for reusable, lower-cost missions.
That's the ideal, right? Building a robust government commercial enterprise and a lunar economy. However, recent setbacks with SpaceX's Starship vehicle, which is one of NASA's 2 lunar landers under contract, the other being Blue Origin's Mark II lander, indicate that these newer technologies are still several years away from being fully operational. This means it's increasingly probable that China will indeed beat NASA back to the moon this decade, winning at least the initial heat of this new space race.
And that brings us to the profound geopolitical implications of this potential shift. Ars Technica recently spoke with Dean Cheng, a highly respected analyst focusing on China, space policy, and the geopolitical aspects of this new space competition. He shed some light on just how significant China's progress is.
Cheng emphasized that the Lanyue lander test is part of China's crawl, walk, run approach to major space projects. He noted that While they can benefit from open information, like NASA's, they still have to build and operate the spacecraft themselves. So these tests, successful or not, are a crucial part of their process.
He also highlighted the successful static test of the Long March 10 or LM-10, their lunar satellite launch vehicle. Chang sees the LM-10, even more than the Lanyue, as significant because it's a new launch vehicle, especially given past issues with the LM-5 and the cancellation of the LM-9, which was their potential Saturn V equivalent. Both of these successes indicate that the Chinese lunar program is definitely pushing ahead.
When asked about the likelihood of China landing humans on the moon before NASA's Artemis program returns, Chang's response was quite direct. He stated, "At the rate things are going, sadly, it seems quite likely that the Chinese will land on the moon before NASA can return to the moon."
That's a powerful statement. And the geopolitical impact, according to Chang, would be enormous. He explained that it would signify the end of American exceptionalism. For decades since 1969, the U.S. has been the only nation to land humans on another celestial body. The saying, "We've put a man on the moon, we can do anything," would lose its resonance.
It would also suggest that China can achieve big things, while the U.S. struggles to replicate projects it undertook 50 or more years ago. This, Chang argued, would certainly affect other nations' perceptions of who is winning or losing the broader technological and ideological competition between the U.S. and China.
He even connected it back to the idea of a Beijing consensus as an alternative to the Washington consensus. While the Washington consensus promotes democracy, pluralism, and capitalism, the Beijing consensus suggests that authoritarianism is more likely to lead to modernization and advancement. If Beijing can achieve these grand space endeavors, it would reinforce that ideological element.
And beyond just the landing, Chang raised an important question about the language of cislunar space. China isn't just aiming for a single landing. Their likely choice of landing sites, such as the South Pole, suggests an intent to establish longer-term facilities and a permanent presence. If they regularly dispatch lunar missions, they could rightfully argue that Chinese should be a primary language, if not the language of lunar and cislunar space traffic management.
Not only that, but China would also have enormous influence over technical and data standards for cislunar activities. The PRC has already indicated it will deploy a lunar positioning, navigation, and timing network, and likely a communication system. This long-term, systematic approach is what Chang sees as China's major advantage, contrasting it with what he describes as the U.S.'s lack of programmatic stability despite its economic and industrial advantages. It's really a complex and evolving landscape. Speaking of powerful forces at play, let's shift gears from geopolitical competition to a truly stunning astronomical discovery. Astronomers have recently captured an incredibly detailed image that's being dubbed the Eye of Sauron, and it's beaming directly at Earth.
That's right, Avery. This isn't a new fantasy film, but a real cosmic phenomenon. This eye is actually the core of a powerful blazar named PKS 1424 plus 240, located billions of light years away. For years, this particular blazar has puzzled scientists. It's known as the brightest source of neutrinos of its kind and also shines intensely in very high-energy gamma rays.
But here's the kicker. Its cosmic jet seemed to drift unusually slowly, which defied the assumption that only rapidly moving jets could produce such powerful emissions. It was a real head-scratcher.
Well, after 15 years of meticulous observations using the Very Long Baseline Array, or VLBA, astronomers have finally gotten an unprecedented look into this jet structure. What they found was absolutely stunning. Near-perfect, ring-shaped, or toroidal magnetic fields. These magnetic fields act like a colossal coiled spring, accelerating particles to extraordinary energies. This mechanism finally explains both the high-energy neutrinos and the gamma rays pouring from this blazar. It's a massive breakthrough in multi-messenger astronomy, solidifying the link between these relativistic jets, high-energy neutrinos, and the role of magnetic fields in shaping cosmic accelerators. It's truly like looking directly into the heart of a cosmic monster. And speaking of rethinking what we see, I want to talk about some new research that's completely changing our perspective on exoplanets. It turns out hundreds of distant planets we thought we knew might be far larger than we ever believed.
That's quite a revelation. How did scientists miss something so significant?
It comes down to how these exoplanets are detected. NASA's Transiting Exoplanet Survey satellite, TESS, launched in 2018, finds planets by observing tiny dips in starlight as a planet passes in front of its star. The size of that dip tells us the planet's size. But here's the catch. TESS has relatively low resolution, and sometimes light from other nearby stars can mix with the target star's light. This makes the planet's shadow appear smaller than it truly is, leading to an underestimation of its size.
So it's like an optical illusion in space?
Precisely. A new study led by Tae Han at the University of California, Irvine uncovered how serious this problem is. They found that many planet sizes have been underestimated by about 6.1%. While that might not sound like much, because density is calculated using both size and mass, a small error in radius leads to a much bigger mistake in density, around 20% too high. This has huge implications for how we understand planet formation, density, and even the potential for life beyond Earth.
So, what does this mean for our search for Earth-like worlds?
Well, it means we might have found fewer Earth-like planets so far than we thought we had. Many planets once classified as rocky, Earth-sized worlds could now be reclassified as larger, less Earth-like planets, perhaps water-rich ocean worlds, or even larger gas layers like Uranus or Neptune. This doesn't rule out life, but it shifts our focus and makes us rethink where to look and how we interpret the data, especially when prioritizing targets for follow-up observations with telescopes like the James Webb Space Telescope.
That truly sheds new light on our understanding of exoplanets, Hannah. And speaking of things that are constantly changing, we have a packed week ahead with several crucial launches across the globe.
Absolutely, Avery. From a highly anticipated Starship flight to unique biological missions, let's dive into our launch roundup.
First up, all eyes are in Texas for the much-anticipated 10th flight of SpaceX's Starship. Ship 37, mounted on Booster 16, is scheduled to launch this Sunday, August 24th, from Starbase. This mission is pivotal as the Starship program is looking to recover from recent setbacks, including the explosion of Ship 36 during a test.
That's right. SpaceX has been working hard, even designing a special mount to static fire Ship 37 on the orbital launch pad after their Massey's test facility was knocked out of service. As we reported last week, on this flight, Ship 37 will deploy 8 dummy Starlink satellites and collect crucial re-entry data before a planned splashdown in the Indian Ocean. It's also notable as the 4th Starship flight of 2025, and hopefully the first entirely successful Block 2 flight if it splashes down intact.
Over in Russia, Roscosmos has a fascinating biological mission scheduled. The Bion M number 2 mission is set to launch on Wednesday, August 20th, aboard a Soyuz 2.1A rocket from Baikonur Cosmodrome. This mission is particularly interesting because its 6,300 kilogram Bion M spacecraft is derived from the Vostok capsule, which launched Yuri Gagarin into space back in 1961.
It's a piece of history flying again. The Bion M number 2 will carry 75 mice and 1,000 fruit flies, along with plants and microorganisms to study how they're affected by radiation at a molecular level. The mission is slated to last 30 days before the spacecraft returns to Earth with its living cargo.
And that's not all for the week. China's CAS Space is flying its second Kinetica 1 mission of the year, carrying 7 satellites to sun-synchronous orbit, including 2 Mexican femto satellites. Russia also has an Angara 1.2 rocket launching from Plesetsk with an unknown payload, likely a military satellite.
Not to be outdone, SpaceX has several other Falcon 9 launches on the manifest. We're looking forward to the United States Space Force 36 National Security Mission, featuring the X-37B orbital test vehicle. and a cargo Dragon flight to the International Space Station, delivering over 2,200 kilograms of supplies and experiments, including studies on engineered liver tissue and bone marrow stem cells. It's truly a busy week in space.
What an incredible day for space and astronomy news. We've covered everything from China's significant strides in the lunar race, potentially beating the US back to the moon, and the profound geopolitical implications of that.
We also delved into the cosmic wonders of the Eye of Sauron Blazar, revealing how magnetic fields accelerate particles to extreme energies, and learned that exoplanets might be much larger than we initially thought, shifting our perspective on where life might exist.
And of course, we wrap things up with a look at the exciting launches on the horizon, including Starship's anticipated Flight 10 and Russia's unique biological mission carrying mice and fruit flies into orbit. Thank you so much for joining us on Astronomy Daily. We hope you enjoyed today's deep dive into the cosmos.
If you did, please consider subscribing and leaving us a review on your favorite podcast platform. Your support helps us bring you more of the latest space news.
And for more updates and all the stories we discussed today, plus all our back episodes, be sure to visit our website, astronomydaily.io. We'll be back tomorrow with more fascinating news from across the universe.
Until then, keep looking up.
Goodbye.